Hi guys, in today's video I will discuss autoregressive distributed lag models. I'll cover the basic concepts, steps to estimate the model, how to test for co-integration, and analyze both short-term and long-term coefficients. ARDL models are great for studying causal relationships and co-integration between variables with different integration orders. Unlike var models, which needs variables to be integrated at the same order, ARDL let us study short-term and long-term causality between stationary variables and those that become stationary after first differencing. A big advantage of ARDL is that it works well with small samples. It doesn't require unit-hood tests to check if variables are stationary, but we still do this test to confirm that variables are integrated at most of order 1. ARDL doesn't work for variables that need second differencing to be stationary. If you're not familiar with concepts like stationarity, unit-hood test, and co-integration, check the helpful links in this video description. And don't forget to subscribe, like, and share to support the channel. Now, let's go through the estimation process. First, unit-hood test. This is important to check if variables are integrated of order 1 in TOPS. Second, estimate the ARDL model. We can use information criteria like Schwarz criterion to select the best lag order. Third, check residuals. We need to ensure they are non-autocorrelated and the model is stable. Next, we check for a long-term relationship using the bound test. If co-integration is confirmed, we include an error correction mechanism. This helps correct short-term imbalance while maintaining long-term stability. If there is no co-integration, we estimate the RDL model in first differences without ECM. The basic RDL equation includes lags of the dependent variable, current and lagged values of the explanatory variables, and the levels. The short-term causalities come from the differentiated variables, and the long-term relationships comes from the variables and levels. The bound test uses F-test. If the F value is below the lower critical value, we don't reject the null hypothesis, meaning no co-integration. If it's above the upper critical level, we confirm a long-term relationship. If it's between the two values, the result is inconclusive. To find the long-term coefficients, it is assumed that the variables are in long-term equilibrium, and after some mathematical manipulation, we can obtain this expression. So, we can see that the long-term coefficient depends on the short-term coefficients. This is the RDL ACM model. Z is the lagged residual from the long-term equation and represents the portion of the imbalance in dependent variable that is corrected each period to return the variable to its equilibrium value. When dependent variable experiences a positive shock, we expect this increase to be gradually offset by downward adjustments until the variable returns to its original equilibrium state. Therefore, we expect the coefficient of Z to be negative, indicating that when there is an imbalance, the system adjusts in the opposite direction to return to equilibrium. Even without a long-term relationship, we can calculate the cumulative impact of variables over time, but in this case, there is no equilibrium to return to. That's it for today. Thanks for watching and happy studying.